Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the topic called Dobereiner's law of triads. You can see the picture of Sir Dobereiner on the screen. So let us start. The classification of elements into groups and the development of periodic law and a periodic table are the consequences of systemizing the knowledge gained by a number of scientists through their observation and experiments. So, the German chemist Johann Dobereiner in the early 1800s was the first to consider the idea of trends among the properties of the elements. So, let us start with all the points of the Dobereiner law of triads. So, the very first point. So, let's come to the theory. The very first point states that Johann Dobereiner was the first scientist to consider the idea of trends among the properties of the elements. So now let's come to the second point. Between 1815 and 1829, he noted a similarity among the physical and the chemical properties of several groups of three elements called triads. I'm going to give you the example in the written part next. Now, and then he gave his law of triads. So now let's come to the third point. According to this law, in all triads of three elements, the atomic masses of this central element is arithmetic mean of the atomic mass of the other two elements, and even all the properties of central element is half the way between the properties of the other two elements. So now let's talk about all the three triads that I'm going to give you. So let me write. The first triad that we are having is of lithium, sodium and the potassium. So what's the second point is saying? Sorry, it's the third point. So what's the third point is saying? According to this law, in all triads, the atomic mass of central element, here the central element is sodium. The atomic mass of central element is arithmetic mean of the other two elements. So let us evaluate it first. So what's the atomic mass of lithium? It's 7. What's the atomic mass of potassium? It's 39. So let us evaluate the arithmetic mean. It comes out to be 7 plus 39 divided by 2. It comes out to be 23. So it proves the third point that sodium got the mass of 23, which is the average of the atomic masses of lithium and the potassium. So this was the first example of the triad. So now let's come to the another example of triad. I'm taking the another example of triad. Let me take its chlorine, bromine and iodine. It's chlorine, bromine and the iodine. So what's the mass of chlorine over here? The mass of chlorine is 35.5, and what's the mass of iodine over here? It's 127. We have to evaluate the arithmetic mean of chlorine and iodine to evaluate the atomic mass of central element called bromine. So let us evaluate it. It comes out to be 35.5 plus 127 divided by 2, and this value comes out to be 81.25. So the atomic mass of bromine is actually 80, which is near to about 81.25. So it is just nearly equal. So now let's take the another example of triads. I'm taking my another example of triad to be calcium, strontium and the barium. It's calcium, strontium and the barium. Here the central element is strontium. We have to evaluate the mass of strontium by taking the arithmetic mean of atomic masses of calcium and the barium. So what's the atomic mass of calcium? It's 40. What's the atomic mass of barium? It comes out to be 137. So let's take its arithmetic mean. It comes out to be 40 plus 137 divided by 2, and this value comes out to be 88.5. So the atomic mass of strontium comes out to be 88.5, or you can say it's actually 88. So it's nearly equal to the average of arithmetic mean of atomic masses of calcium and the barium. So now let's come to the another example of triads. My another example of triad is sulfur, selenium and the tellurium. Sulfur, selenium and the tellurium. Here again the central element is selenium. So we have to evaluate the atomic mass of selenium by taking the arithmetic mean of atomic masses of sulfur and the tellurium. What's the atomic mass of sulfur? Is 32. What's the atomic mass of tellurium? It comes out to be 127. So now let's take their arithmetic mean. It comes out to be 32 plus 127 divided by 2, and this value comes out to be 79.5. So here the mass of selenium is actually 79, which is merely equal to the 79.5. So here again we can say that the atomic mass of selenium is average of atomic masses of sulfur and tellurium. So these were the 4 triads that I have given. So let's come to the fourth point over here. Let's talk about the drawback of Dobereiner law of triads. The fourth point states that, the drawback point states that the main drawback of this classification was that this concept was applicable only to the limited number of elements, but not applicable to all the known elements at that time. So this was the drawback. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.